right, this is geometry. Today we're going to review and cover lessons 4 and 5 of chapter 14. So chapter 14 is really goes from regular polygons to circles. What makes a polygon regular?
If its sides are equal.
Sides are equal and angles are equal. If it is a regular polygon, then we know it is cyclic. What does that mean?
It means that it's a circle can go around it.
Correct. A circle can be circumscribed such that all the angles are inscribed in the circle. All right. Do you remember how to calculate the angles in a regular polygon? Like if I have
180 plus
yeah,
times 180.
180 for 3 of the angles, and then add
Minus 3 times.
so n minus 3, no, n minus 2, because we need 1. So for a pentagon, the sum of those would be 180. We add 180, we add 180, right? So 180 covers 3 of them, the angles, and we just add 180 for every angle over it. All right, remember we had lines that we called, that looked like that. What was that called? A what?
Radii.
A radii. Yeah, so that was a radii. It goes from the center to the vertex. And then we had lines that looked like that, and that was called an apothem. Goes from the center perpendicular to the side. Because it's regular, it also bisects the side. Now, do you remember how we calculated angles? Yes.
You divide them by like the number of triangles to fit into it.
Okay, divide what? So particularly for this pentagon,
Divide 360 by 5.
you take 360 all the way around divided by 5. And that's what that angle is. Okay, I'm going to draw it a little bigger. All right, so what is 360 divided by 5? 72, right? 360 divided by 5 is 72, I think. All right, so if that is 72 degrees, then could y'all tell me those angles? What would be true about those two angles? Why would they be equal?
More like sides that are equal.
Right, because those are both radii, and all radii are equal. So those two angles would be what? 180 minus 72, which is what? 108. Then what would I do with the 108? Divide it by 2, so those angles would be 54. Okay, now, what is true about, well, first, what is this called? Y'all tell me what this, you have to know, you're going to have, okay, so y'all, this is review. You're going to have to know the names of regular polygons. This is lesson 1, review. We are reviewing because I haven't seen you in a whole week. All right? What is this called? It's called a hexagon. What is unique about a hexagon?
It has 6 sides.
Has 6 sides. What else? Yes. The radii make equilateral triangles. That's only true in a hexagon. Got it, author? Mm-hmm. Such that all the radii equals the length of the sides, and all of the angles are 60 degrees. Now, if I draw an apothem, it makes what type of triangle?
30, 60.
A 30, 60, 90, and we have our Pythagorean triplet. All right? That's really lesson 1. You need to know everything about a hexagon. I have made your next test. And you should know about hexagons because they are unique. All right? What is the perimeter of a regular polygon? Perimeter and area. The perimeter is 2 N, capital N, R. But what is N?
Number of sides times 180.
Number of sides times not 180, but a trig. Yes. The sine of 180 over the number of sides. So, if we know how many sides and the length of the radius, then we can calculate the perimeter. Now, we may also have to calculate the radius, but remember we can make right triangles, always. With the apothem, half of the side, and the radius is always going to make a right triangle in a regular polygon. Got it? All right. What is the area? What's the formula for the area? Do y'all remember? It's a proper way to call a man. We call him,
MR squared.
yeah, Mr.
Mr. Square.
Yeah, Mr. Squared. What does the M stand for?
N times sine of 180 divided by N times cos of
Times what?
cos of 180.
Cosine? Yeah. So we can find the area of any regular polygon. Now, the more sides we have, the closer the value of n comes to what? The more sides we have in a regular polygon, the closer the value of n approaches what value? Pi. Because 2 pi r is what? 2 pi r is the circumference of a circle. The same is true with Mr. Squared. The more sides we have in a regular polygon, the closer the value of m approaches the value of pi, and the area of a circle is what? Pi r squared. And that is what lesson 4 is on. So if you're with me on page 592. There's an image on the top of that page. And they compare perimeter and the number of sides in that table on the left-hand column. And it shows you, like, when we get to 3,072 sides, that value of n approaches the value of pi, 3.14. All right, the circumference. What does the circumference measure? The circumference measures what?
2 times pi times the radius.
Yes, and what does it measure?
Oh, the whole thing around.
The length, yeah, the length of the circle on the outside only. Circumference is almost like the fence in a yard, right? It's length. So circumference is tied to length. So if you're asked, what is the length of this portion of a circle, you're thinking circumference. It's one-dimensional. That, in that case, always when it's one-dimensional, we only have terms raised to the first power. All right, look at the definition of the circumference. The circumference of the circle is the limit of the perimeters of an inscribed regular polygon. It is the absolute limit. It's the largest number of sides you can reach. That's what it's talking about, of any polygon, such that it becomes a circle. It's the absolute limit. Like, you cannot have any more sides to a polygon once it reaches a circle. Does that make sense? That's what it's saying. Now, this is not the only formula for circumference. What's the other one? What's 2r? 2 times the radius. What does that equal in a circle? The diameter. So pi d is another formula that you can use for circumference. All right, so that's lesson 4. And we're going to come back and work some problems. All right, 5. Actually, today is 5 and 6. Today is lessons 5 and 6. So now we're on lesson 5. All right, the area of a circle. So notice how close the area of a circle. Liam, we're on page 598. The definition of the area of a circle is to the circumference of a circle. The area of the circle is the limit of the areas of the inscribed regular polygons. So it means the same thing. It's the absolute limit of number of sides you could have for any polygon such that it now becomes a circle. And on page 599, there's a table on the right-hand column, and it shows that as the number of sides approach, and you're looking at Mr. Squared, that value of m approaches the value of pi. There's not another formula for a circle, the area of a circle, other than pi r squared. So, if on a test I gave you the radius, you should be able to calculate perimeter of a regular polygon, area of that regular polygon. You should be able to calculate, well, I'd have to give you, for the polygon, I'd also have to give you the numbers, how many sides it had, right? If it were a circle, you could calculate the circumference and you could calculate the area, right? But what if I gave you the area? Could you calculate the radius? Okay, what if I told you the area was, let's just say 56 centimeters, 56 centimeters squared. That's the area. How would we calculate the radius? You would set it equal to pi r squared. You set it equal to the formula. Then you would divide by pi. Does everybody have their calculators? Such that r squared is 56 divided by pi. But to get r, you would then take the square root. So it's the square root of 56 divided by pi. Luke, did you do that? What's the square root of 50? Helen, you got it?
I'm not. Do you use type of 3.14?
No. Use pi.
Oh, no.
Pi is shift what?
X times 10 to the square root of x. It's
Let me see.
in the middle, bottom middle.
Okay, bottom middle. Did you find it? Okay, it is on your calculator. Use pi. Helen, what'd you get for the radius?
4.22.
4.22. Anybody else get that?
Yes.
Did you get that?
What do you type in?
Square root, put in a fraction.
Any fraction?
No. The fraction button, you know. And then you're going to put 56 over, and you're going to input pi, which is shift. Do you see pi on your calculator?
Yeah.
Okay.
And
And
equals.
equals 4.22.
Yep.
Okay. What if, could we do the same with a regular polygon? Could we calculate the radius if I give you what kind of polygon it is and the area? Yeah. If I tell you what regular polygon it is. Okay, you want to try it? Okay. Here's what I'm going to give you. The area of, let's say, a hexagon, because I like hexagons. The area of a hexagon, we'll stick with, let's not stick with 56 because we're going to come up with not far off of that. We'll go is 112 inches squared. Okay? Tell me what the perimeter is. What if I asked you that? Could we do that? What would I have? Yes, Arthur?
Would you just divide? 112 by 6.
I.
What did you divide?
112 inches squared equals.
Oh, there we
two,
go. 112 equals 2.
and,
What's n? It's a hexagon.
6.
oh, 6.
6 times the sine, 180 over 6.
What's the cosine?
Times one.
Well, times the cosine, yes, because I am in, yeah. Times the cosine, good job. 180 over 6 times r squared. So I need to use this to solve for r.
Well, then you don't need the 2.
That's right. This is area. Don't do the 2. I went to perimeter. All right, so somebody get this number for me. 6 times the sine of 180 over 6 times the cosine 180 over 6.
Three square root of 3 over 2.
3 square root of 3 over 2. All right, how do I solve for r squared? Show me the algebra. I have 112 equals 3 squared root of 3 over 2 times r squared.
You divide 112 by 3 square root of 3 over 2.
Divide both sides by 3 square root of 3 over 2. That eliminates that. So what is 112 divided by 3 squared root of 3 over 2?
43.1.
Somebody else confirm.
Yeah, 43.108.
108, okay. But that's r squared. How do I get r? I take the square root, so what's the radius?
6.566.
You agree? Now can I calculate the perimeter? Yes, I have the radius. And I go to 2nr. Got it? So what's 2 times 6 times the sine of 180 over 6 times 6.566? So perimeter is going to be 2, and here's my n, 6 times the sine of 180 over 6 times my radius, 6.566. What's the perimeter?
39.396.
Everybody, somebody else confirm? Is that right? All right, so given the area or perimeter of a circle, I could calculate the other one. So if I give you the area, you could find R and you could calculate the perimeter. If I give you the perimeter, you can solve for R and calculate the area. Are you following me? Did everybody follow that? Same thing with the regular polygon. If I give you the area, you can calculate R and then give me the perimeter. If I give you the perimeter, you can find the value of R and give me the area. Did you follow that?